Okay, boys and girls, today we're going to be talking about real-world problems using one-step equations. I've shown you in previous videos how to solve an addition equation, subtraction equation, multiplication, and division equations. So now we're going to put them in a real-world context, and you need to come up with an equation based on the context and then solve it. All right, so I'm going to start with addition, and here's the problem. It says a wildlife reserve had 8 elephant calves born during the summer and now has 31 total elephants. How many elephants were in the reserve before the summer began? Okay, so we had some unknown number of elephants before the summer began. Then we added 8 elephants to that total, which gave us a brand new total of 31. Okay, and I hope everybody understood this. We started with some unknown number. We added 8 baby elephants over the summer, and our new total was 31. Okay? So, in order to solve this kind of problem, we need to use the opposite operation of addition, which is subtraction. We can subtract 8 from both sides. That leaves me with just the amount of elephants that were in the beginning of the summer. And then when we subtract, we get 23. So this tells us that there were 23 elephants at the wildlife reserve before summer began. All right. If we wanted to verify it, we could always plug in 23 plus 8. Does it equal 31? 23 plus 8 does happen to equal 31, so 31 equals 31. All right. That's that one. Now, let's talk about a subtraction problem. Let's separate this right here. Now, Ellie spent $88.79 at the computer store. She then had $44.50 left over to buy a cool hat. How much money did she originally have? Okay, so we're looking for the original amount, so we don't know what that was, but we do know that she spent $88 of it and 79 cents at the computer store, and that left her with $44.50. Okay, so what we want to know is find out how much she started with. So this is a subtraction equation, so we have to perform the opposite operation, which is addition. Okay. Oops, that's not right. Getting extra stuff in here. Hold on. All right, so we want to add $88.79 to both sides. Okay. Here, they're going to cancel out. Leave me with just the x. And if I add $88.79 to my already $44.50 on this side, what I'm going to wind up with is $133.29. And that's how much she had in the beginning. Okay? If we want to verify this, we could take it, plug it in here, and say $133.29 plus $88.79. Does that equal $44.50? So much for my dividing line. It really didn't work, did it? All right, so we just add these two numbers together. 132, no, we don't add, we subtract, dang it. All right, we started with 133, and we subtracted 88.79 from it. All right, so we subtract, we get 44.50, and we have 44.50 over here. So we know that it is a true statement. All right, let's talk about multiplication. All right, it says Carmen participated in a readathon. Mr. Cole pledged $4 per book, and he wound up giving Carmen $44 total. How many books did Carmen read? Okay, so this is a simple multiplication problem. He pledged $4 per book, and she read some unknown number of books, but we do know that he wound up giving her $44. Okay, so multiplication, we undo using division. We divide both sides by 4. The 4's cancel, leave me with just A. 44 divided by 4 is 11, so she must have read 11 books. If we want to plug this back in, we can say 4 times 11, does that equal 44? But 4 times 11 does, so we know that's a true statement. Okay, next we'll wind up with our division problem. All right, now stick with me on this because this is kind of lengthy. Jorge baked some cookies for his math class. Jorge's a good kid, baking cookies for math, I tell you that. All right, for his math class's end of the year party. All right, there are 28 people in his math class, including Jorge and his math teacher. So When everybody's in the room, there's 28 people. Okay? He baked enough cookies for everybody to have 3. So not only did they just get, they got 3 cookies, all right? I wish I had Jorge in one of my classes. We'd have cookies all the time. All right, so anyway, he baked enough for everybody to get 3 cookies. How many cookies did he have to bake total? All right, so this is a division problem, okay? This is a division problem. We want to start with some unknown number of cookies. How many cookies are we going to have to build or make or cook? And we got to divide that unknown number by 28, okay? Because there's 28 people in the class. And that's going to give me 3 cookies for every person. All right, so to solve a division problem, you have to undo it with multiplication. So we multiply both sides by 28. These 28s cancel, leave me with just the C, and then 3 times 28 is 84 cookies. So he made a total of 84 cookies, and everybody in the room got 3. If you want to verify that, plug it back in. You say 84 divided by 28. Does that equal 3? Well, 84 divided by 28 does equal 3. And we wind up with 3 equals 3, which is an equation.